On May 11, 2026, three separate breakthroughs converged to prove the foundational rules of how AI is built, trained, and sold had turned inside out. For years, the industry followed a specific set of laws. To make an AI smarter, you built a larger, more opaque neural network. To move a robot, you hand-coded its motor functions. And to win the market, you relied on agile startups to outrun the legacy tech giants. But those methods eventually hit a ceiling. Within a single news cycle, the leaders of the AI boom revealed they were abandoning the very methods that defined their initial success. To move forward, the tech world executed what we can call the Great Inversion. They started doing the exact opposite of what worked yesterday. The first reversal happened in software. For years, we trained AI using deep reinforcement learning, systems that learn by trial and error. But this method has a fatal weakness: catastrophic forgetting. When an AI learns a task, it builds a specific pathway of connections. But when it tries to learn a second task, it overwrites those invisible weights. It scrambles the connections it just built, learning the new skill while deleting the old one. OpenAI researcher Jia Wang proposed a radical solution called heuristic learning. His team stopped training the neural weights entirely. Instead, they used an existing model to observe an environment and write explicit, human-readable Python code to navigate it. They tested this on Atari Breakout. When the digital ball got stuck in a repetitive loop, the AI didn't blindly adjust millions of parameters. It wrote a specific Python script to add an offset to the ball's trajectory, instantly pushing its score to the theoretical maximum. The irony is clear. To make artificial intelligence perfectly retain its memory, engineers had to regress back to traditional logic code. While software is moving toward code, robotics is doing the opposite. Machines are throwing their code bases away. Traditional robots relied on vision, language, action models, scripts that told a robotic arm exactly how many degrees to rotate each motor to pick up a cup. But hand-coding physics for every object and obstacle is too slow for the real world. This friction led NVIDIA's Jim Fan to announce the World Action Model, a concept currently powering the new Figure 03 humanoid robot. These machines learn physics natively by watching thousands of hours of first-person human video. The robot intuits how to move by observing our muscles and joints, bypassing hard-coded motor instructions entirely. Digital AI needs the rigidity of code to remember, but physical AI needs the fluidity of a neural black box to survive the chaos of the real world. The final inversion is economic. In the previous era of tech, you made money by selling hardware. Today, hardware has become a Trojan horse for something else. Google's screamless Spitbit Air costs just $99. Google isn't trying to profit on the device. It exists solely to lock users into a $10 a month subscription for their Gemini AI health coach. This shift is also killing the traditional startup. Training a foundational model now requires capital reserves that used to be the territory of sovereign nations. Look at the Chinese firm DeepSeek. They recently closed a massive $7.35 billion funding round backed by state-level wealth. Their entire model runs on domestic Huawei Ascend chips, proving they can bypass international supply chains. AI development has exited the venture capital phase. It is now a race for sovereign infrastructure and national power. What happens when an AI can perfectly remember through code, move through neural nets, and scale through sovereign capital? We saw the result in an experiment by mathematician Timothy Gowers. He gave GPT 5.5 Pro an unsolved doctoral-level problem in number theory. The model moved past simple pattern matching to generate an entirely original scientific proof, independently reducing a complex mathematical upper bound. This timeline projects that original thinking into the physical world. According to NVIDIA, robots will pass the physical Turing test by 2028, the moment you can no longer tell if a task is being performed by a human or a machine. The technology has escaped the browser window and is now embedding itself into our factories and our economic reality. You shouldn't ask if AI will disrupt your industry. The real question is how quickly you can adapt to a landscape where the old rules of technology are